Hello, welcome back to Pre-Calc. This is a video over Unit 9, Section 6, and what we're going to be doing today is we're going to be solving trigonometric equations, okay? So what we want to look at first is our sine function, okay? And before we do anything, let's do this, okay? Let's just say we have the value sine of x is equal to 1/2, okay? And what we're doing here is we want to solve this equation here for x. Remember that this value here is an angle measure, okay? So when you're solving trigonometric equations, the input that you're solving for is the angle measure. So you have to sit there and you'd have to ask the question, okay, well, what angle measure is going to give you 1/2? And if you think of the unit circle, and we just draw out a unit circle real quick, we can kind of just answer that question, and that's going to be pi over 6, okay? That's when the y value on the unit circle gives me that value. But it also happens over here, okay, at 5 pi over 6. So simply just using the unit circle can be a little bit confusing. So, and another way we can think about this, and the proper way that we would actually go about solving this would be to give sine of x is equal to 1/2. You can think about it intuitively and say that, x is going to be pi over 6. We already know that. But another way for us to figure that out is to do what's called an inverse trig function. So what we would do, inverse means we switch our inputs and outputs. So we can write this as sine inverse of 1/2 is equal to x, okay? Or we could also use the words arc sine, okay, of 1/2 equals x, and they all mean the same thing, okay? You can use a calculator to do this depending on the problem. A lot of times they're designed for you to answer these with exact values from the unit circle. But let's talk about this 5 pi over 6 negative and pi over 6 business over here, okay? Looking at this graph, if I look at this graph of the sine function, okay, this is a function. Okay, so this is a function, meaning that it passes the vertical line test, okay? However, the inverse is not, which is a problem, okay? That's why we're getting multiple answers here to solve this equation. Sine of x equals 1/2, and knowing, well, where does that exist? Do we do 5 pi over 6? Do we do pi over 6? What's going on? So here's the thing. If I were to restrict the domain, so if I restrict the domain, and let me write that over here, restrict the domain of our sine function from negative pi over 2 to pi over 2, okay? And simply just look at this window here, all right? And let me highlight this part here in red, okay? So this part of the graph, all right? If I restrict my domain to just that part of the graph, then the inverse is also a function. And we can tell if the inverse is a function if it passes the horizontal line test, okay? So if I just look at the red part of this graph, it satisfies both the vertical line test and the horizontal line test for us to evaluate these, okay? So in an inverse trig function, okay, what we do when we're solving these, we have to restrict these domains, okay? And we have to look at it from -1 to 1 on our sine function, okay? So now if we ask that question, all right, well, what value gives us, if we ask the question, if the x value, what is it, 1/2, okay, so the inverse trig function, okay, so in the inverse, if my input is 1/2, okay, here's 1/2 on our graph, okay, here, and so we only get the value of positive pi over 6. We don't get other values on that graph. Okay, so that's why we would only choose that. Now, this also depends on, the type of function you've got and all that good stuff. Okay, so what I like to do, let's just quickly talk about the inverse trig function domains. Okay, so let's talk about this. Let's write this down in our notes. The inverse trig function domains. All right. All right, and let's list off their ranges as well. Okay, so this is just standard depending on what we've got. So let's first look at, if we look at the inverse, y equals sine inverse of x, okay, the domain for that would go from -1 to 1, okay, and the range would go from -pi over 2 to pi over 2, okay? And we can see that from this graph here, all right? Notice what happened here was we switched it. So like we restricted our domain of our sine function from -pi over 2 to pi over 2. Those things change, okay? Notice how the domain of this function, okay, is the range of my inverse and vice versa. The range of my function is the domain of my inverse. Okay, that's how we get -1 to 1. All right, let's list off y equals cosine inverse of x, okay? And that's also got a domain from -1 to 1 and a range from 0 to pi, okay? So that's a little bit different, okay? Tangent inverse of x is going to be all real numbers. So let's go from -infinity to infinity. And then our range goes from -pi over 2 to pi over 2. Okay. And let's just use those for now to kind of help us out. Okay. So solving these, can be a little bit tricky, but let's just go through and see what we can do. But as long as we have these written out so that we kind of know what our domains and ranges are, that'll help us when we're solving these. So if I evaluate this guy, sine inverse of the square root of 2 over 2, all right, what I want to do is think about, the equation sine of x is equal to the square root of 2 over 2. So which angle on the unit circle gives me a y value of square root of 2 over 2? Now, if you think about it, because our domain on our sine function is restricted to -pi over 2 to pi over 2, all right, it's only going to happen here at pi over 4. Okay, so in this case, if we were to evaluate this, I usually have to go back to my original trig function, okay, if it's written in inverse form. But what I do is I just simply just write, okay, x is going to equal pi over 4. And that's how you solve, okay? So it's pretty easy to do. There just are some weird things you have to consider when you are solving these, okay? Over here, tangent inverse of -1. Now, on this guy, I can still do, and let's do this. Okay, so let's think about this. When I write tangent inverse of -1, I like to think of tangent of what angle measure gives me a value of -1. Now, when I'm solving this, because we got a bunch of different options, when I'm solving this equation here, I have to consider, even though this is the range of my inverse function, my domain for x, and I'm just going to write this out, my domain goes from -π/2 to π/2. Okay? And so you have to think about this, because those are the angles we're given, we're dealing with, you know, quadrants 1 and 4, going from -π/2 to π/2. And what I know is that if I do, you know, I'm looking to see where my x and y values are the same. So at √2/2, √2/2, I have that value there. This is √2/2 comma -√2/2. Okay, and so the way I would answer this to figure out my value for x would then be, I would want to use my -π/4 angle on that. Okay, you wouldn't want to use 3π/4 because that wouldn't be in our domain for my inverse tangent function, or my tangent function. Okay, so if you're given this inverse tangent function and being asked to evaluate it, okay, use your regular tangent function to think about it and draw your unit circle, and then x is simply just going to give you -π/4, and that's how you'd solve that. So again, I'm not doing like a whole lot of work. It's just a lot of thinking and knowing what are you looking for, okay? All right, let's take a look at something that is a little bit strange, okay? So solving this basic trigonometric equation. So I have cosine of x is equal to -0.25. Let's rewrite this for cosine of x is equal to -1/4. Now, unfortunately, this point is nowhere on our unit circle, so we can't figure it out, okay? One thing we do want to think about is our domain for the cosine function. So we are restricted on cosine to, so our domain here on this trig function goes from 0 to pi. Okay, so our domain is restricted here, okay? So cosine of x is equal to -1/4. Now, in order for us to do this, what we want to do is use a calculator. Okay, so this would be a calculator question. So I would want to do cosine inverse of -1/4 is equal to x, okay? And let's find this both in radians and degrees. So let's do radians first, and then we'll do degrees, so it kind of makes sense, okay? So if we were thinking about in degrees, you know, our domain would go between 0 and 180 degrees, okay, if we're talking about this in degrees, okay? So let's get out our Desmos and we'll figure it out. Okay, so if we plug this in into Desmos, we get an x value of, in radians would be 1.82 radians. Okay, but in degrees, we did it in degrees and I did both. This would give us a value of 104.48 degrees. Okay, so both of those, you know, would be the same thing. All right, just depending on what you're asking. Probably want to do radians, probably what it's going to be in, but yeah. All right, there it is. Okay, an object hangs from a spring that is stretched and released. The equation d equals -4 cosine of π/3 t models the distance the object in inches above or below the rest position as a function of time t in seconds. Approximately when will the object be 3 inches above the rest position? Okay, so let's do this. So we want to, so let's first do this. Let's label our variables. I know that t is equal to time in seconds, okay? I also know that d is equal to 3 inches, okay? So what I want to do, and let's do this. Let's just quickly graph this so that we have an idea as to what's going on here. Okay, so what we want to do on this, and this is where it gets a little quirky. If we look at a graph, here's time 0, okay, on the x. What we do is we pull this thing down, okay, it is stretched and then released, and it gives us this harmonic motion, and it'll tell us how far above and below the resting point of that object is, okay? We wanted to know approximately when will the object be 3 inches above the rest position. That means that we have a positive 3 here, okay, that the distance is 3 inches above. And so this is what we call a position graph, meaning that we can have a negative position from our resting point, okay? So even though we would hit -3 down here, we're looking for the y value of positive 3. And when the first, at what time will that object be 3 inches above the resting position, okay? So we can graphically solve this. We know that the answer is going to be t equals 2.3 seconds, okay? And you can always solve these kinds of things graphically, okay, which is nice. But we can also do it by hand, all right? And so what I want to do is plug in 3 into that equation. So I've got 3 is equal to -4 times cosine of pi over 3t, okay? And so we're going to solve this. And so this is going to kind of be one of those questions where it's not as easy as it typically seems, okay? Now, here's what we've got. What I'm going to do is I'm going to isolate my cosine. So in order to solve this, I want to divide both sides by -4, okay? And so I have this value, -3/4 is equal to cosine of pi over 3 times t, okay? Now, the next thing I want to do is this. I'm going to do what's called a u substitution, okay? So I'm going to let u equal pi over 3t. And the reason why I do that is because I have an angle in here, and I have this variable that I'm multiplying by pi over 3. So I can't exactly solve this the way that I was in the first one. If I do a u substitution and plug that in, I can. So now I got this. I got -3/4 is equal to cosine of u, okay? Now what I'm able to do, and again, because I have -3/4, I have to use a calculator here, but I'm going to do cosine inverse of -3/4 is equal to u, okay? Now, the other thing that I can do on this, I've solved this equation for u, okay, and I've written it out as cosine inverse of -3/4. That's an exact value. What I can now do using that u substitution is I could rewrite this as cosine inverse of -3/4 is equal to pi over 3t. And to solve for this, I would multiply each side by 3 over pi, multiply this by 3 over pi. So if I wanted to find what t is, okay, I could plug this in the calculator. And you don't have to do the u substitution on this one necessarily. You could kind of just do the inverse the way that it is. But t would equal 3 times cosine inverse of -3/4 all divided by pi. And we know what we're supposed to get. We should get 2.3. Okay, so let's go ahead and plug that into Desmos and see what we get. Okay, and so if we plug this guy in, we do get the same thing of 2.3. Okay, and so that's how we would answer that question. So graphically, we can do it. Okay, also algebraically, okay, depending on what tools you have available. Okay, solving trigonometric equations by factoring. Now, what I want to do here, we have our domain here, okay? Our domain for this is going to be that x is between 0 and 360 degrees, okay? This is where things do get a little interesting, okay? The first thing I want to do is set this equal to 0, okay? And so if I subtract a sine x from both sides minus sine of x, what we're going to get is I'm going to get sine squared x minus sine of x is equal to 0. Okay, so now that I've done this and I've set it equal to 0, notice what you have here, okay? This is the form of a quadratic, okay? Think of this equation here, all right? And this is what helps me. If I think of x squared minus x equals 0, how would you solve that? What you would want to do is you'd factor out an x, and you get x minus 1, set it equal to 0. Okay, and then you set x equal to 0, and then you set x minus 1 equal to 0, and you solve for x. Okay, so you can solve these equations by factoring. But what you want to think about here is that you have trig functions. We're going to do the same thing. Okay, what I can do here is I can factor out a sine of x. Okay, and you're left with sine of x minus 1 then is equal to 0. Okay, now what I'm going to do is I'm going to solve the equation sine of x equals 0, and I'm going to solve sine of x minus 1 equals 0. Okay, so over here, and I want you to think about your unit circle here. And I want you to think about all the values on your unit circle. What angle measure here gives you a y value of 0? That would occur at 0 degrees. And it would also occur here at 180 degrees. So in this case, and the reason why I'm using the entire unit circle is because we have set our domain to be between 0 and 360. So I'm using the entire circle here. Okay, so now what I have is I have solved this equation, and I just say x is equal to 0 degrees and x is equal to 180 degrees. Okay, now if I have sine of x minus 1, okay, here I'm going to add 1 to both sides. Okay, so I have sine of x is equal to 1. When I'm solving this, I'm asking the question, what angle measure gives me a y value of 1? That value would be up here at pi over 2. And that's the only place where that happens. So here, x would be equal to, and that's 90 degrees, since we're dealing with degrees, 90 degrees. So if we were to solve this equation, we're actually going to have 3 solutions that make this true. And so x, in this case, is going to equal 0 degrees, 90 degrees, and 180 degrees. Okay. Now, remember how we restricted our domains and did all that? That's for like solving just a generic equation. The reality is, if I didn't restrict this domain, let's say my domain here was all real numbers, how many different solutions would I have? Infinite. You'd have infinite. Now, there is a way for you to kind of figure that out, and we'd have to write that algorithm out, but that's what we got. Okay. All right, we've already done this one. I don't know why it popped up twice. That is my bad. You can just cross that out. Okay, but let's talk about this next one, identities and trigonometric equations. Now, what I want to do here, I want to solve this stuff here. Yuck. I've got sine squared of x is equal to sine of x times secant of x minus cosine squared of x. What we want to do is manipulate this so that we get a usable value. Also, our domain is restricted between 0 and pi over 2. Okay, so the first thing I want to do here is I'm going to add cosine squared of x to both sides. And I'm going to do that because I recognize on the left side that I'm going to have sine squared x plus cosine squared x is equal to sine of x times secant of x. Okay? Now, sine squared x plus cosine squared x is 1. So 1 is equal to sine of x times secant of x. Now, secant, let's rewrite that, because still right here, I don't have much, okay? But what I can do, let's rewrite secant. So I've got sine of x times 1 over cosine of x, and this is over 1, okay? So if I multiply those together, I've got sine of x over cosine of x is equal to 1. And what I've got is I have the value of tangent of x, okay? So I went from something very, very, very complex, okay, down to something simple and usable, all right? Now, because our domain is restricted between 0 and pi over 2, which is nice because that's just in quadrant 1, all right, I know that my value is going to be pi over 4, okay, because that's when sine and cosine are the same, okay? And so what angle measure gives me a tangent value of 1? Okay, so tangent of one angle gives me 1. What I'm looking for is when x and y are the same, because when those divide out, they'd give me 1, okay? So I know that x, in this case, would be equal to pi over 4. And that's how we solve equations.